Thank you everyone for joining. This is the second OSCAL Foundation webinar that we are hosting. And happy to have everybody here to sit and listen. The plan for today is to have a roughly 30-minute introductory educational session in which I will be diving into the OSCAL layers and models that make up OSCAL. After that 30-minute session, we're going to be turning over to our guest panelists who are going to be here to answer your questions about the practical use of OSCAL, the ways in which they personally and at their organization have taken advantage of the OSCAL layers that I'm going to be talking to you about today. So if you have any questions for either me or for our panelists, go ahead and submit them throughout the course of this presentation. At the end, we will be going through questions and discussing them in a panel format with our two guest panelists. So with that, I'm going to go ahead and jump into our 30-minute educational session. My name is Stephen Banghart. I am the technical coordinator for the OSCAL Foundation. Originally, I was part of the team at NIST that helped put together OSCAL many years ago, and am now happy to be continuing to work with OSCAL in the capacity of the OSCAL Foundation. The OSCAL Foundation is a nonprofit that has been founded to centralize and coordinate the greater OSCAL community. We help facilitate the adoption, education, development, internationalization, and extension of OSCAL through our work in various working groups and across the OSCAL community. As I mentioned, this is the second webinar in a series of three. The first webinar that we put on was a 101 guide to OSCAL. If you missed it, the recording is available online at this link, or you can find it in the events archive on our website. This presentation is assuming that you have the rough knowledge level that you would have gotten if you had watched that webinar or if you got that introductory knowledge from somewhere else. So we're going to be skipping some of the most basic introductory concepts about OSCAL and really focusing in on a little bit more of the intermediate level. We're still not going to get extremely technical. That material is going to wait for the third webinar. But this should give you a good look into the capabilities and practical applications of OSCAL. As a refresher of our acronym here, OSCAL stands for the Open Security Controls Assessment Language. And when I say this, I mean each of these letters stands for something that we believe is core to the OSCAL Foundation. O, open, is always developed by an open communities of stakeholders. That's true for the standard itself, and that's true for the OSCAL Foundation. We use OSCAL to communicate about security controls and other related items. OSCAL does more than just describe security controls. It drives assessment and other processes, and it's a well-defined and standardized machine language. So let's jump then into the meat of our presentation. OSCAL, when it was originally designed, was meant to reflect the reality of the manual processes that had been being done for compliance and risk management all around the world. OSCAL is intended to be able to map to that non-automated version of a workflow without duplicating it entirely. When we do risk management and compliance activities, there are a tremendous number of steps, components, pieces, and elements that go into building this greater whole. And recognizing that, OSCAL is built the same way. When we say OSCAL, we're really referring to a collection of components that have been created to map and express those different steps and processes that make up risk management and compliance activities. And to do that, OSCAL has split things up into 3 layers and 7 models grouped within those layers. The ultimate vision is to replace all of those steps with the equivalent OSCAL version. But due to its design, We can substitute pieces of these processes with the OSCAL and automated versions as the capabilities develop. So what are these 7 models and 3 layers? Here is an overview. Our 3 top-level layers are the controls layer, the implementation layer, and the assessment layer. Within controls, we have 2 models, one called catalog and one called profile. In implementation, we have 2 models called system security plan and component or component definition. And in the assessment layer, we have 3 models, the plan of action and milestones, assessment results, and assessment plans. Over the next 20 to 30 minutes, we're going to go over each of these layers, and we're going to go over each of these models. And we're going to examine them as they reflect a process that came before, understanding what exactly it is that they improve upon, the specific process or component of risk management and compliance that each of these models seeks to substitute. First, we're going to look at the control layer. And what I want to do is establish some foundation in terms of terminology and concepts. These are understanding what this layer means in a general context, including OSCAL and the non-automated approach. When I say controls layer, I am trying to capture how compliance requirements, controls, regulatory frameworks, and various risk management activities tend to start with the definition of a large set of controls, a catalog or framework that provides a set of things that we can then reference later. This is often a control catalog, is the language that we use to describe this, but it can be any collection of metrics, requirements, guidance, and controls that make up some large document or set of things to represent a set of possible items to be referenced later. When I say profile, this is a word that in OSCAL we say profile, but elsewhere in compliance and risk management, this is sometimes referred to as a baseline. So I may be using profile and baseline interchangeably throughout this presentation. In OSCAL, we call the model the profile. Profiles are subsets of catalogs. They are some collection of controls and often collections of parameters that change or modify a catalog. For example, you can think of the FedRAMP low, moderate, and high being a profile of NIST SP 853, which is a core catalog. I'm going to go into more details into exactly what those relationships mean, and more importantly, how those relationships are expressed in OSCAL. So in the original workflow that many of us are familiar with today, a catalog is published by some authoritative or neutral body, typically as a large Word, Excel, or PDF document. Most of us are familiar with the catalog that drives a lot of our regulatory frameworks and compliance activities, which is NIST SP 853. After that catalog exists, organizations publish profiles based on that catalog. Sometimes that's the same organization that made it. In this case, we're familiar with the NIST SP 853B, a set of low, medium, and high profiles based on that catalog. But there's also ones made by organizations that are not the original author of the catalog. As I mentioned earlier, think of the FedRAMP low, moderate, and high profiles. Those are subsets of controls taken out from SP 853. And then those profiles go on their merry way to various other compliance processes down the workflow chain. Okay, this makes sense. This is a workflow that is pretty standard when it comes to risk management and compliance. To represent this in OSCAL is a very clean mapping of these concepts into a machine-readable, machine-processable format. The OSCAL catalog model is the machine-readable piece of OSCAL that allows us to express this catalog piece. So instead of a large Word, Excel, or PDF document, an authoritative or neutral body would instead publish an OSCAL catalog. That is the specific purpose of that model inside OSCAL. Similarly, when we talk about an OSCAL profile, it is a roughly one-to-one mapping of the activity of publishing a profile that references some subsets of controls. But instead of doing so in text, an OSCAL profile directly references an OSCAL catalog to provide the same functionality as it would in the original workflow. So you can see this has a pretty clear mapping, right? OSCAL has specific models inside of it that have specific purposes and specific jobs to do specific tasks and to substitute specific elements of an original workflow. Some details on these OSCAL models. An OSCAL catalog is a machine-readable expression of a catalog of controls. It contains a well-formatted, machine parsable structure that is specifically designed to be able to encode any of the information that is present in the wide variety of control catalogs out there today. Obviously, we're familiar with SP 853, but there are countless other frameworks and catalogs that can be represented in this format. And it contains the exact same information. And I think this is the key and the reason why I took this approach to explaining it. We're taking a non-automated process, the publication of the catalog, and we are directly mapping it into an automatable process, creating it as an OSCAL catalog instead. It contains all of the same information at a minimum, and at the higher end can include significant amounts of metadata and useful information that the original catalog author or somebody else enhancing that catalog could include in the OSCAL document itself. A profile, similarly, is a machine-readable expression of a profile or baseline. It defines a subset of controls, and it can set parameter values to define a complete baseline. To go a little bit more technical on a OSCAL profile, the capability of a profile allows you to select any number of controls from any number of catalogs and combine them in a wide variety of ways. In the most standard one-to-one mapped relationship between an OSCAL profile and its non-automated version of a written profile, you typically only reference one catalog. But in risk management activities where multiple frameworks are often being applied, OSCAL profiles can capture the fact that multiple catalogs may exist and may be relevant to your enterprise. So that's a brief overview of the controls layer. There's a clean one-to-one mapping of a OSCAL catalog replacing and enhancing the non-automated version of a catalog, and an OSCAL profile being a clean machine-readable substitution for how we would previously publish a profile or a baseline. These are designed to be referenced by the rest of the OSCAL models. So as we go through the implementation layer and the assessment layer, remember that all of these things reference the machine-readable fields of the catalogs and profiles. This enables a traceability following a specific line of implementations and assessments backwards, leading eventually to a specific pointer to some element inside of a catalog or a profile. And this is where a lot of the value of OSCAL comes from. It's being able to connect the disparate pieces of a very complicated process together, weaving them together in a way that makes it more useful. So what is the implementation layer? When I say implementation layer, when OSCAL says implementation layer, what we're referring to is trying to capture the risk management activities taken by a specific enterprise or an information system owner, is sometimes the term that we use. These are the activities that those groups use to attest to their compliance or adherence to some profile or baseline. This is a pretty common situation. We have some regulatory requirements, compliance framework, or risk management guidance that we want to implement at our enterprise inside of our information system. We want to be able to say we adhere to requirements A, B, C, and D through methods A, B, C, and D to express that in a concrete way, both for compliance, but also just for our own internal management of these things. To that end, a system security plan, sometimes called a control, related to a control implementation worksheet or similar concepts, depending on the framework that you're coming from. An SSP, at the end of the day, is a collection of statements of compliance and of adherence against some given profile. In the FedRAMP world, this is also called an SSP and would be written against one of the three profiles that FedRAMP provides: low, moderate, or high. Um, and we're going to talk about components. I do want to make a note here that for this specific element, the component, this is more of an OSCAL specific term and not something that shares a word in the risk management world quite as cleanly. So I do want to caveat that and have you keep that in mind as we talk about components, that this is a little bit more of an abstract concept. It does make it a little bit harder to grasp and to talk about. So for the purposes of this presentation, I'm providing a little bit of a simplified view of what a component is. Everything here should still be correct, but would encourage you to do further research or attend our third webinar if you're interested in digging into components more closely. When I say component in the context of this presentation, I'm talking about the abstract grouping of one or more capabilities that satisfy the controls or guidance or requirements that are stated in a baseline. For example, if you in your information system have a piece of antivirus software, we could consider that one component that meets some number of requirements that you have to have. So let's do the same thing we did for the controls layer. Let's look at the non-automatic, non-automated approach and understand how that maps into the automated future that OSCAL helps enable. The first step any enterprise goes through is they write a system security plan. This is tremendously difficult and time consuming. We trivialize it a little bit by putting it just here in one box on this page. This is difficult. You put together a large document that explains their compliance with controls and requirements. This is typically a large Word file. Sometimes there's a template you follow, but at the end of the day, somebody is by hand going through a number of controls or requirements and answering each one, explaining how their information system implements that given requirement. Alongside that, you provide evidence that these things are true. You write a statement that claims how you've implemented something, and then you include evidence that helps affirm that. It could be screenshots, log files, software inventories, vulnerability reports, countless number of possibilities for what counts as evidence. That's included alongside or in the system security plan. And that package is then sent onwards to auditors or reviewers. So let's map this into our understanding of the OSCAL models, the OSCAL layers, and understand how this is implemented from an OSCAL perspective. The OSCAL SSP model is a mapping of a traditional system security plan. This is a machine readable way of packing that information into a document and providing a linkage both up the chain to the profile that we're implementing and down the chain to components and assessments, which we'll talk about in a moment, to allow the entire process to be automated. So this contains largely the same information that a system security plan would hold, but with those pieces of connective tissue that allow automation to be possible. You could consider OSCAL components as a way of implementing specifically the evidence that we use to affirm a given control. For those of you that are very familiar with OSCAL, you might balk a little bit at this simplification of the concept, but I do think it's helpful to understand components as a way, in a machine readable way, of expressing the specific ways in which we have successfully implemented the requirements or controls that are expressed in a given baseline. Then, of course, the OSCAL SSP, alongside all of its associated OSCAL components, collectively make up a package, similar to what your package might look like in the non-automated approach, which is then sent off to auditors and reviewers. System security plans contain a lot of information, and the OSCAL model version of an OSCAL of a system security plan contains a lot of information as well. It contains human readable metadata. There is, if you think about the introductory sections of most SSPs, if you're familiar with building one, there tends to be a number of chapters or sections that cover metadata about your information system. Items that are not specifically related to controls but are still required as part of the process. This is also captured and represented in a system security plan OSCAL model, alongside more specific and technical component definitions that allow us to drill down and understand which specific capabilities of my information system are implementing which specific controls. There is a decoupling between system security plans and component definitions, and this is where some of the aforementioned complexity comes in that we're not going to be covering today. Component definitions are a way of defining the capabilities of your information system in a way that allows them to be referenced by multiple system security plans. And this is really something relevant for information systems that are beholden to multiple regulatory or compliance or risk management frameworks. The same capability as part of your system may help you reach compliance against multiple compliance frameworks at the same time. And the OSCAL models in this layer allow for and support that. We'll be talking more about OSCAL component definitions in particular in our third webinar when we talk about how some of these items are implemented specifically. So we understand the controls layer creates a definition of requirements, guidance, or controls. Implementation layer allows an information system itself to express how it is compliant with those controls. The third step of this process then is assessment. This is when a third party will be able to verify or check that the statements and affirmations made in the implementation layer are in fact actually true. This is a process that exists in our non-automated workflow. There are countless auditors, reviewers, regulatory bodies that will take a compliance package, will examine the claims within, and then decide to what extent those claims are true. Inside this layer, we have an assessment plan. When I say assessment plan, I mean a set of instructions and processes that need to be executed in some order in order to complete an assessment or in order to establish continuous monitoring. This is often referred to as a security assessment plan or a SAP. In OSCAL, we refer to it as simply an assessment plan. An assessment results is perhaps self-explanatory, the results of executing an assessment plan. This is what actually contains the results of testing whether or not these items are in fact compliant. This is often called a security assessment results or a SAR. And finally, we have a plan of actions and milestones or a POAM. This is the documentation that an information system owner creates to explain how they're going to remediate any issues following an assessment. For those of us that are familiar with this compliance process, these three things should be fairly familiar. We understand how these items are used. So in that workflow, we have an auditor come in and compare the state of the system against the claims in the SSP. We're familiar with that. The assessment results are captured in some set of documents. And if there's anything that needs remediated, a plan of actions and milestones is drafted and put together. The OSCAL models map to the assessment layer in a clean one-to-one fashion. The OSCAL assessment plan model is a specific document format that allows us to capture the information that's inside of an assessment plan. The OSCAL assessment results model captures the output that this reviewer would create after following the assessment plan and reviewing the items in question. And finally, the OSCAL POAM model is the machine-readable OSCAL document that allows you to express the same information that would be in a traditional POAM. This one-to-one mapping makes it fairly easy to understand what specifically these items do. An OSCAL assessment plan is a machine-readable expression of the same steps and tasks that are in an assessment plan. This means that some of them are going to be human readable. There are some assessment plan tasks that only a human can complete. It's also going to contain machine actionable tasks that can be executed at some endpoint or on the enterprise network or information system itself. And crucially, this assessment plan references an OSCAL SSP and an OSCAL profile. There is an end-to-end understanding that this assessment is being done against a system defined by an OSCAL SSP, and that assessment is being done against a known profile or catalog expressed by an OSCAL profile or catalog. There are connections between each of these layers that allow us to trace everything back up and back down again. Assessment results, in the same vein, is machine-readable expressions of these results. They include any evidence that might have been collected by the auditors and reviewers, and provides links to related assessments and other models. This is particularly important when we're talking about continuous monitoring or assessment cycles. Typically, assessments are not done in a vacuum, and OSCAL understands that reality and provides the information that we need to link to past assessments and to lay the ground for future assessments in a machine-readable way. And finally, the OSCAL POAM, just like assessment results, allows for an organization to create a set of plans, actions, and milestones that link directly to OSCAL concepts defined in the other model documents. So looking over the full set of layers and models of OSCAL, we can see that we define our controls in a controls layer, and these are typically published by some authoritative or neutral third party, though they don't have to be. And that includes a catalog, which defines the overall set of controls or requirements, and profiles, which define some subset of those controls. Next, the information system or enterprise or network in question implements those requirements. And they do that using the OSCAL system security plan, which provides a way for them to express how they are implementing a given set of controls, and component or component definitions, which allow them to be explicit about just how those controls are being met in a way that can then be automatically assessed during the next stage. And in the assessment layer, we allow the assessor or the auditor and the information system, as represented in the implementation layer, to interact in a machine-readable and actionable way. These assessments are written against and parsed in the understanding of having a system security plan in OSCAL that can be referenced and directly worked on. So that was a very brief overview of the OSCAL layers and models. And I hope that after this, you understand that when we say OSCAL, we're really referring to a set of capabilities that together allow us to cover the entirety of the risk management and compliance world. It's the combination of these things and the links between them that really enable the automation that makes OSCAL special. With that in mind, I would like to introduce my two guest panelists. First, I have Travis Howerton from RegScale and Pirooz Javan from Easy Dynamics. These are both OSCAL Foundation members whose organizations have been frontrunners in the world of implementing OSCAL in their tooling and in their products. And they are here to talk to us about the practical applications of these OSCAL layers and models and to discuss the specific ways in which they're putting these things to use. So uh, please submit any questions that you may have had about OSCAL and about the practical applications of OSCAL, and we will get to your questions as time allows. First, though, I'd like to give our speakers a chance to introduce themselves and their organization briefly and say a few words about how they are putting OSCAL to practical use. So, Travis, could you please start us off?
Sure thing. So I'm Travis Howerton, one of the co-founders and CEO here at RegScale. By way of background, I spent 20 plus years in national security, retiring as the first chief technology officer of the U.S. nuclear weapons program, where I got a lot of firsthand experience implementing RMF programs at scale, and always was frustrated by the manual nature of what it took to generate those documents, read them, assess them, and was very excited to see what NIST did with OSCAL and what the foundation has taken up to really push industry forward. And so the part I'm excited about in the layers, I'm a developer by classical training, I have a computer science background. The thing I like about developing is you develop code and you've got a compiler, and that compiler enforces a strict set of rules to make sure you color inside the lines. It's going to tell me where I'm out of bounds and throw errors. It's going to give me warnings for things that don't quite look right. But I don't have to pay a human to go review my code and find those things for me. The compiler does. I think the really cool use case. So when I think of OSCAL, a lot of people say, well, so what? How would I use it? I understand it's a data standard, but how does this save me time, money, and energy? My answer to that is think of it like a software compiler. If you've got applications that collect all this data against the OSCAL standard, publish it in machine readable formats, now your compiler can say, are you in my risk envelope or out? And you can get that answer instantly versus spending days, weeks, or months with humans trying to get to the same place and with greater precision. So it just creates this really strong foundation for automation that can really reduce the burden on the entire industry that's been dealing with this. And in my case, going back a couple of decades now. And so for the first time, I think there's hope that these things can be automated. And I think OSCAL is a fantastic standard for that automation.
All right. Thanks, Travis. And Pirooz?
Awesome. Well, hello, everybody. My name is Pirooz Javan. I'm the CTO and co-founder of Easy Dynamics. Appreciate the opportunity, Stephen, to come out here and talk a little bit about OSCAL layers. We've been involved in OSCAL community for several years now. We run the OSCAL.io website and kind of help evangelize through meetups in the local area in Northern Virginia for OSCAL discussions. And as I kind of think about OSCAL and the journey we've taken, we bring a slightly different perspective. We are a systems integrator, so we go to projects and we have to implement technology that meets certain regulatory requirements. And what I can tell you is through our experience that without the guardrails that Travis is talking about, we enter a wild array of variance in how risk management is conducted at organizations. So what I really like about OSCAL is, like anything else, it's a standard, and it's meant to elevate us collectively to meet a higher degree, but a higher degree of accuracy and granularity. But the standard also provides flexibility to meet us where we're at today. Where a lot of organizations do have variance in how they're managing their risk activity. And I think that OSCAL did a really good job, at least the participants, Stephen, yourself, Michaela, the folks that worked on the OSCAL standard, really did a good job of creating the flexibility to meet us where we're at in the market today. As I think about like an example of one of the journeys we took, the model that comes to mind is profiles. About a year and a half ago, we won a project where we had to go and implement a federal system, and we had a very aggressive accreditation timeline. And when I mean aggressive, I mean weeks, not months. And the organization, in particular here, public sector organization, published all of their cybersecurity requirements on their website. So they raised transparency. That was great. But when we looked at them, there was 20 PDF files, each one separated by control family. And I would say over 50% of the controls were tailored. So the journey that implementers and folks that need to prove the burden of proof as with the system owners to go through and reconcile what's been tailored out of a PDF document and copy all that content into Microsoft Excel files and Word files. It took us 2 weeks just to rationalize what kind of compliance. And in a scenario where we're trying to shift that ATO from months, years down to weeks. It's a challenge when we're dealing with tailored controls, highly not a machine readable format, and the friction is just too great. So we quickly hung on to OSCAL and have been working on tools to help us accelerate our journey in making this a lot more streamlined.
Great, thanks, Pirooz. And I want to build on what you just said there. You mentioned that the profile model was a key part of that. Could you say some words about how the profile model and the automation capabilities that it brings were helpful for you in that use case?
One is in the machine, because the machine readable formats store the metadata. The profile model would allow us to quickly see what's been removed and what's been added. That alone, when you're looking at 20 files, each file being 60 to 100 pages of controls, and manually having to determine what's been tailored, especially when a lot of us, we're comfortable with 853, we're used to it, but a lot of organizations do tend to tailor it. So the profile model for us really helped us distinguish what's been tailored, what's the standard control where we may have already met that control based on the system that we were delivering, and that allowed us to focus purely on what's been tailored.
That's great, thanks. And Travis, I want to ask you, kind of in a similar vein, you mentioned the great work the organization has been doing. Is there a specific OSCAL model that has been really enabling to your use case? One in particular that you could say some words about?
I think I'd probably go with components if I had to pick one as sort of a significant innovation in OSCAL. Because when I got into the industry, we thought of things in broad boundaries, and so the key was what was in your boundary, what was outside your boundary, and there was a lot of gamesmanship played and sort of how that was done to be able to get to an outcome. But in general, what you want in security is precision. And so you want that boundary to be as small as it can. And so what I like is this idea of a component. And the analogy that my friend Anil would use if he was here that I like because it's simple is the M&M analogy. For years, we did boundaries like an M&M, hard on the outside, soft on the middle. You could kind of move around. What we want is a peanut M&M so that every component that's part of my system has been evaluated. We know how it's hardened, what controls go in it. And so if you think about where like I would like to see industry go is when I go to any hyperscaler, let's think of AWS, Google, uh, uh, Oracle, Microsoft, any of the big ones, there's a catalog of services. It tells me what it does. It tells me what it's going to cost me, whole bunch of information, but it doesn't give me a whole bunch of information on security. I'd love to see every service have a component definition saying which controls it satisfies, how you harden it, and how you should assess it. And what that would do is allow tools like us to just add it to your shopping cart. Like which components make up my system, I'm going to add them. Now, a lot of my documentation becomes self-updating for me. I can take more credit for what the cloud providers are doing. I think things like that are going to push the industry forward once we get to mass scale adoption.
Great, thanks. And maybe we can use that as a segue into one of our audience questions here, a little bit more technical, asking for some guidance on how to understand what a component and component definition really is. And I do think this is worth talking about because this is a common point of confusion when it comes to OSCAL, is this specific meaning and definitions when we talk about components. So the question is, Regarding the component layer, can you clarify if this layer, and I think they mean model, the component model, if this model is intended to describe how a component implements a control, or the capabilities that the control possesses that may be used to implement the control? And I think they mean the capabilities that the component possess that may be used to implement the control. Um, so yeah, I think this is a nuanced question and trying to drill down to what exactly a component is expressing. So Travis, maybe we can start with you. You have just talked about components.
Yep.
To you, how do you see a component and how does it fit into the bigger picture?
Yeah. So I'll sort of answer it in two parts. And so if you think about a big general support system, GSS, in the past life, you'd have to get a big asset inventory spreadsheet together by some sort of manual means. What you can do with components is group them. So maybe I've got a load balancing component that has a collection of F5s, and I have a storage component that has a collection of NetApp storage arrays and whatever it may be that I've put together in my system. My mental model is for each component, you should describe the capabilities that component has to meet a certain set of controls. So the profile is going to tell me all the controls I need to hit to meet that baseline. Now, the F5 example, they're not going to be able to hit all 325 controls in a moderate baseline. It's not going to happen, but there's going to be a set of them they do help with. If they could define those and then describe the capabilities for how they do it, how you would configure it, and then how you audit it, I think that makes life easier for practitioners everywhere. And I think it makes life more consistent for the vendors because now there's a well-documented roadmap to security. We lock things down the same way based off vendor best practices, and we know exactly which controls we can attest against. So I think of it more as the capabilities in the component, with the component being a logical grouping of like assets. That's my mental model. Opinions may vary, but that's how I think about it.
And Pirooz, I'd love to ask you about, if you have anything to add to Travis's mental model of components. But more than that, I'd love to hear how you feel that component and component definitions are part of the the overall automation approach and how it enables automation up and down the full OSCAL set of models.
Yeah, sure. I think Travis brought up a good point. I think you think about storage arrays, you think about web servers, a component, and we had this conversation just the other day at our office. What's a boundary? Just like you have an authorization boundary, what's a boundary that you want to describe a component? And there's no right or wrong answer. And one of the things that we're looking to do is pretty much start broad at the SSP level, knowing that the power of components are at the granular level of the reusability of the components, but start broad and then start to break down the view that you look at your information system logically within that authorization boundary. And what I like about components and what we're starting to explore more is how granular we can go. And because of the hierarchical nature of components, meaning it's the one of the models that actually references itself so that you can have this hierarchy of components within each other. And I think to answer, try to come back to the direct question, there are ways to describe the capabilities and reference the implementation of those capabilities directly to the capability. So you can correlate it directly to the capability, or you can describe it in much more abstract, just overall component, what all of the capabilities are. So there's some variance and flexibility in how you do that. What we're evaluating right now is thinking through how we can get towards all the way granular down to an SBOM and how that would affect component definition architecture within an information system. Because the transparency right now from our customers we're seeing is they want to get down all the way down to the weeds. So the component definition activity that we're doing or exercises we're doing is really associating both SPDX files and Cyclone DX files to the component definition and using that somewhat as what we traditionally look at as technical reference models within organizations. So I have approved software, I have approved components. I can go through the assessment criteria, and what gives me the advantage in the component definitions is that correlation, that traceability all the way back to a control. So that's for us the high value. of the component definitions.
I'd love to pull the thread a little bit on SBOMs. This is a conversation that comes up frequently when we're talking about OSCAL. People want to know how do SBOMs, to what extent do they interact with or interface with OSCAL? So, Travis, I'd love to ask you first and say, where do you see SBOMs, software inventory, and related concepts interacting with OSCAL in practice, and where do you see them helping each other advance their own goals?
Yeah, 100%. I view them all under the umbrella as compliance as code, where each of them have a standards-based representation of some security domain. And I think these are two of them, but there's actually three in my head. So I think of OSCAL on the definition side, defining controls, catalogs, what it is you need to do. I think of SBOM as going sort of into the ingredients list of what's in your software, your supply chain, being able to look at that level. There's another standard called OCSF, the Open Cybersecurity Schema Framework. It's a Linux Foundation project. I view them as sort of runtime security. How do I take information about phones, assets, configurations, other things, and pull that through for my runtime? And then I think about OSCAL on the tail end as the publishing standard for how you then assess it all. So now that you have all this rich data coming in machine readable ways, how do you normalize it, publish it out in OSCAL, and then run it through your compiler to say, am I good or am I bad? And what should I do about it? And so I see all those things working together in an automation ecosystem that's all standards based, that can provide end-to-end solutions for the first time. We have machine readable representations of all these things, and we're getting broader and broader tooling support. So I think the key is to get more adoption in the vendor community, not just for folks like us who are building tools on OSCAL, but for these security vendors, the cloud vendors to publish more in these domains. And then these automation problems become simpler computer science problems to solve. And so I think it's exciting to see how they all work together.
Yeah, no, I agree. I think that both SBOMs and OSCAL are indications of the direction that things are moving in terms of machine readability and interactability being the focus of the future of security,
Mhm.
cybersecurity and risk management. Absolutely. I want to ask a little bit about the last layer of OSCAL, the assessment layer. I think that this is probably one that most people are less familiar with. I want to ask, and we'll start with Pirooz. How do you feel that the implementation and control layers provide information and automation support to that final stage of this process? How does assessment and auditing interact with, from an automation perspective, the data and information that's present in the implementation layer? And why do you think that makes assessment easier and better for everybody?
Oh, Stephen, that was not a softball.
It's the end
uh,
of the webinar. We need
yeah,
some bigger
no,
questions.
well, so there's multiple camps we have at Easy Dynamics, and one is that there's if I'm moving towards automated assessments, then my reliance on the system security plan is less, meaning I want to hit the live system and I want to conduct an audit of the live system. I don't want to see how somebody's described that live system in a system security plan. But what we did recognize is that the SSP gives us key insights in the data that we needed to conduct the assessments. One was, and the main one was having the list of components. So one of the things you mentioned earlier around moving from human assessments to machine-based assessments, the first minute we looked at SAPs and saw the list of activities that were human-driven activities, we said, well, those can be all machine-driven activities. And what I love is that there's no shortage of machine tests that are out there. Meaning, if you go to GitHub and you find test frameworks, there's a lot of test frameworks for a lot of different environments. But to trigger those test frameworks and say, well, this test correlates with that control, that connectivity tissue is in the SAP. So the SAP gives us, for us, the first time to really correlate a lot of machine tests to controls for a component that's defined in the SSP. So if we evaluate an SSP and we say, oh, there's an Entra ID component here, there's an Azure Blob storage component here, there's another component here that, and assuming the SSP has that, what we're working on in our innovation labs, and we've successfully done this in the DoD as well, is building that full automated path of evaluating the SSP and interrogating the live system to produce those results. And the SAP not only has the activities in it, but what I also like is it's got an area for tasks. So if you have, let's say, a test framework that has 1,000 different tests in it, and one example that is a Maester framework. It's a Microsoft framework that, not to promote it, Microsoft framework that tests Office 365. Correlating all those activities to controls and also being able to determine what tasks frequency to run those tests on. I may want to run some monthly, I may want to run some weekly. All of that is rich data within the SAP that gives us that context on not just what to test, but how to test it and when to test it.
Great. That's a great answer. Thank you, Pirooz. Travis, do you have thoughts on the same on this
Sure.
front of assessment and how OSCAL is playing into this?
Yeah, we're seeing sort of three sort of mainstream ways to assess. One's technical controls and leveraging automation. Some of the cloud providers will provide attestations. You can do things in configuration tools like Ansible, run playbooks, check state. There's a growing ecosystem of tools. You can do it via manual means like STIG, CIS, other things to see where you're at. But that's only like 30% of the controls, maybe 40% of the controls. A lot of the other controls are programmatic. That's where we're seeing techniques like AI that can look at things, evaluate, and sort of hit what I'll call the softer side of cyber, and evaluate those sorts of things without putting in a human, regardless of how it's being assessed, or if you're just still sitting a SCA out on rounds, a security control assessor. If they're logging in a tool that's got an OSCAL Foundation, you can still publish it in OSCAL and run it through that compiler at the end as well. So it gives you sort of multiple ways to check things from AI to automation to OSCAL, all working together to drive better risk outcomes for customers. Because at the end of the day, that's what all this stuff's about. We spend so much time creating paperwork to prove we're secure versus actually doing the security work. I'd like to see us get into a state where we almost take it for granted that all the paperwork becomes more self-updating and automated, and that we're more focused on driving risk out of our environments. And I think standards like OSCAL are part of the foundation of how you get there.
Excellent. Great. And for our last question for the day, I want to ask a little bit of a forward-looking question. And Travis, we'll start with you. I'm curious if there is a capability either within OSCAL or enabled by OSCAL that is at the forefront of your organization's research and development. What's that next new thing that is practically enabled by OSCAL that you're currently working on discovering or exploring, and could say a couple words about it?
Yeah, I'd say like the big push with us is we built a platform that was OSCAL native from day one. And so we're a next generation GRC that's built on OSCAL. And so we started there. But the thing we're really spending a lot of time on today is what is possible with AI, routing of things, assessment of things, and then leveraging OSCAL to publish back out. And the thing about AI is it's generally right, but it's not often precisely right. And so if you've used it in coding tools and other things, you see the same thing. Like it does really clever stuff where you feel like it's a genius, and then it does stuff like, why would it ever think that would compile? Right. And so it's a mixed bag, right? And so I think the precision of the models in OSCAL that you can train on under the hood can really enable some AI use cases on precision that matter in this space. And so I think the combination of expressing the RMF as code and then layering on AI is, I think, the aggregate of those two things is going to be very disruptive for this industry.
Yeah, OSCAL as an AI enabler, I think, is a great future work, like the next step.
Yep.
Pirooz, for you and your organization, what's the next big thing? What's that cutting edge piece that you're exploring either within OSCAL or enabled by OSCAL?
So, as an integrator, we provide services, and it's not uncommon for our prospective clients to ask us, "What are the capabilities that you have? What do you bring to the table?" And so we do a lot of software development, and the area that we're spending a lot of time on is what's the right pattern that if we build the software with the right context, right information, including some information around how we're securing specific areas of our software. How do we go from infrastructure as code and software to compliance documentation? So we're streamlining that process right now internally and really evaluating whether it's OPA, Caverno, other tools out there that we're leveraging to help us enforce the security policies. We're you know automating the flow into our compliance documentation so that we really have one source of truth, and that's code. We update that, and we can flow through to update the compliance documentation automatically.
That's great. It's great to hear that, OSCAL has these practical applications, but that there is a wide world of possibilities out there still that we're exploring, that we're looking into, that we're expanding into. Makes me feel like there is a future where OSCAL is capable of so much more than it already is.
Yeah,
Uh, oh, go ahead, please.
no, I was going to say last week we had a great event at the Plug Fest, and I think a lot of the vendors that were there were able to demonstrate that we were able to exchange compliance artifacts. It was our first time integrating our files with other vendors' tools and integrating their files with our tools. So it was exciting to see what we see today, a lot of signals that are out there, but now in a standardized format that each tool can represent that same information. So it was a great event.
Yeah, we've been seeing great signals of organizations implementing OSCAL and coming together to prove interoperability, to prove the fact that it's in use today and being exchanged today in useful ways. So it is great to see. And with that, we're going to wrap up our 1 hour webinar. I would like to thank very much our two guests, Travis Howerton from RegScale and Pirooz Javan from Easy Dynamics. Really appreciate both of you taking your time to talk today about OSCAL. It means a lot. Thank you both.
Thanks for
Um,
having us.
of course.
Thank you.
For the rest of our attendees, thank you for attending our webinar. A recording of this session will be made available on our website. If you're interested in getting involved with the OSCAL Foundation, learning more about OSCAL, or contributing to the work that we're doing to advocate for and develop OSCAL, please head over to oscalfoundation.org. That is our website. There you'll be able to learn a little bit more about our mission and what we're doing. On our Get Involved page there, you'll be able to find links to join our working groups where some of this work is being done, or you can just join our generic announcements and news list to learn more about upcoming events like this one. So thank you everybody so much for attending, and I hope you have a great rest of your week.